All right, final video for chapter 1, combining sections 1, 3, and 1, 4 into one section of notes in case you happen to be reading the textbook that is posted in my Open Math. Okay, so our overview for these couple of sections is this. Just because someone makes a conclusion it doesn't mean it's correct. Okay. You have to understand how the study was conducted to know what you can and cannot conclude. Okay, so it's not just about looking at the statistics, the final results, and saying, oh, well, obviously that's it. You really have to dig in. You have to dig a little deeper. You cannot just take it at face value. Okay, you have to know how this study was done. All right, so let's take a look here at the first example. So a recruitment office's data analyst finds there's a strong positive relationship between height and salary. So what this means is that the taller you are, the higher your starting salary when you're recruited. Okay, so would this then somehow mean that a job candidate should wear platform shoes to their interview? I would really question that. Okay, I certainly don't think that that's going to be the case, but we'll talk about why that is. Okay, so is this an observational study or a designed experiment? All right, so first let's define the two. So in an observational study, okay, you are simply observing. So you have some information and you record it, or you can look through maybe a list of records, or you can look through historical information and you're just recording what is happening or observing what has happened. Okay. In a designed experiment, this one's a little different. I don't want to use this word in a bad way, but you manipulate the environment and then you observe. Okay, and by manipulate, again, not necessarily a negative connotation there on the word manipulate, but maybe you're doing research about how plants grow with a certain fertilizer. So by manipulating the environment, you might give some plants no fertilizer, some plants a little bit, some a little bit more, etc. That's manipulating the environment. Telling one group to do sit-ups and another group of people to do push-ups and another group to jog in place to maybe see what happens with heart rate. That's manipulating the environment, okay? And then recording what happens. So in this example, which one do we have going on? Do we have an observational study or do we have a designed experiment? In this example, we have an observational study. Okay, because again, we are not manipulating anyone's height, nor are we manipulating anyone's salary. We're simply taking some information we have. Hey, we know how tall these people are, or we can ask them how tall they are, and we know what their starting salaries were. Okay. All right, so explanatory variable. What is an explanatory variable? This is generally what happens first. Okay, you might have heard of this in other places as the independent variable. Okay, and this is the one that explains or impacts the other variable. All right? So as we look at this example again, which one do we think is the explanatory variable? Do we think that the person's height, or are they trying to say, sorry, that the person's height impacts their salary? Or are they saying that the salary that they are given when they get hired impacts or has an effect on how tall they are? Okay, well, I'm not sure either one of those is a great one, but certainly the salary you make has nothing to do with how tall you are, right? So here, our explanatory variable would be the person's height, okay? Height would then impact the salary. All right, so response variable. This is the one that happens second. You might have heard it called the dependent variable in other courses. Okay, and this is what happens as a result of. Okay, so this is a result of the explanatory variable. Okay, so again, in this example, the salary is what is the response variable. So we're saying that the height is the explanation for the salary. Okay, the salary is the response. So obviously, I think we know that that's not legit, that's not true. So that leads us to what it means to be confounding. Okay, a confounding variable, or what it means to be confounding, is that not all, turn my pen on, sorry, not all variables that affect the response variable are measured. Okay. So what do we mean by that in this particular example? Okay, there are lots of things that impact salary. That were not considered in this scenario. Okay, a short list. For example, your degree, your years of experience, your location, honestly. I'm in a big, huge city versus a small town, etc. Okay, so those are all things that weren't considered that definitely could have an impact on what's going on. All right, a lurking variable. A lurking variable is a variable that affects both the explanatory and the response variables. Okay, it affects both of them, but it also isn't measured. Okay, isn't measured. Sorry, I think my pen is losing its juice right now. All right, so a variable that affects both the explanatory and response variables, but it isn't measured. So it's sort of like a lurking variable, except it's a special lurking variable in that it impacts both response and explanatory variables. Okay, so here, it won't be the degree. Okay, the degree has nothing to do with somebody's height. Years of experience has nothing to do with how tall you are. Your location has nothing to do with how tall you are, but there is one variable out there that does impact both your height and how much money you make. And sad but true, especially for the ladies out there, gender is the one I'm talking about. Okay, women tend to be shorter on average, and women tend to make less money for doing the same job as their male counterparts. All right, and then what could the data analyst do to determine causation? Okay, so if you want to show that there is causation, causation means is the explanatory variable causing the effect, the difference, if you will, seen in the response variable. Sorry about the noise in the background. That would be Teddy chewing on an empty milk jug. All right, so to show causation, and this is a really important note here, to show causation, you must have a designed experiment. Okay, if you don't have a designed experiment, you cannot show causation, beginning and end of story. Okay, so real quick, we've got a few down here at the bottom to go through. Again, feel free to pause the video and try these out on your own if you would like. Your choices are observational or experiment, or in some cases, maybe you can't tell. All right, first, an apology. My page 13 apparently didn't want to download whenever I took in the notes, so I'll just write out C, D, and E here by hand. So reading through, you should have an observational study, so nothing was done to or for these women. They're just asking women who were in shelters, what did you have more satisfaction with, the shelter outreach clinic or the government clinic? No manipulation, again, not using a negative term, but no manipulation. For the second one, that is an experiment because one group is being given half the amount of medication as another group. So there's manipulation there of what's going on. C, the conservation agents net the largemouth bass. Again, that's observational. They are not giving them parasites or removing parasites. They're just seeing who has them. D, it's honestly hard to tell. I would hope that would be an observational study. It could potentially be unethical to tell people to consume a lot of caffeine. We know it's not necessarily the greatest thing for your body, so that would be a little harder to tell. Again, I'm hoping it would be an observational study. And then E, for the 7th graders, since one has traditional techniques and the others has reform method, that is an experiment. And so then after that, it says, circle the studies where a conclusion of cause and effect is possible. Well, that goes right back to what we said right prior to example 2. Right here, to show causation, you must have a designed experiment. So the ones of these that can show causation would be B with the rats and E with the 7th graders. All right, so on to example 3. This is one that I'm going to have you think about and work on your own. We are going to discuss all of example 3 in a live discussion when we meet online together. But what I need you to do is read through those 5 different scenarios and see if you can find what issue, what problem there might be from a statistical standpoint, okay, in terms of bias, in terms of honesty, whether something was, all on the up and up. Did they apply a conclusion in a right way? Just kind of brainstorm and see what you can think about, and that'll be part of our discussion again when we meet in person.